Okay, welcome to the lesson on pulley systems part 2. You can take notes on a separate piece of paper. It's going to be a brief set of notes. Okay, pulley systems part 2. So we're going to take a look at this example here today. So what we have is a mass resting on a table and a free hanging mass attached to that. So they're going to move as a system in the downward direction. And it acts basically like the same as the pulley system that we saw before. The only difference is this mass is sitting on a table and there is some friction there. So we're going to start by drawing a free body diagram for each mass. So if we take a look at this diagram, over here, the 1.8 kilogram mass is going to have a force of gravity acting down. That's the positive direction because as we saw in the last set of notes, the direction that the system moves is the positive direction. And then there's going to be a tension force pulling up, and that's negative tension. And then over here, you're going to have a tension force pulling on the block in this direction, and that's positive tension. And then you will have a frictional force pulling back in this direction, force of friction. And we're just gonna put a negative sign here because it's opposite the direction of motion. There's also two other forces here that are not acting in the direction of motion. They cancel out, so we kind of ignore them. But you have a force of gravity acting on this mass, and you have a normal force acting on this mass. But they cancel out, so we kind of ignore them. They don't work in the direction of motion. So if we wanted to draw a free body diagram for each mass, we could. The 3.8 kilogram mass, we have the force of gravity, F normal, tension, and F friction. And then for the 1.8 kilogram mass, we have two forces, the force of gravity and the tension force. So those are the two free body diagrams and an analysis of the forces, all of the forces acting on the system. Okay, next we're going to find the net force on the system. Okay, so along the direction of motion, we can find the forces that are acting. So again, we ignore the force of gravity and the force normal on the 3.8 kilogram mass. So some of the forces in the direction of motion, you have Fg, we'll call it Fg1, acting on mass 1, the 1.8 kilogram mass, minus the tension force acting on the 1.8 kilogram mass, plus the tension force acting on the 3.8 kilogram mass, and minus the force of friction acting on the 3.8 kilogram mass. So this tension force and this tension force cancel, and so we get Fg minus F friction is the net force on the system. And we can plug in our values for that. So it becomes 1.8 times 9.8 minus 3.8 times 9.8 times 0.35, which is the coefficient of friction. So this is a 3.8 kilogram mass times the 9.8 gravity and times the coefficient of friction 0.35. So it's the force of friction that we're calculating. And if we calculate that, we get 4.6 newtons. So that's the net force on the system. Very similar to how we calculated the net force on the pulley system from the last set of notes, except we have friction acting, we have to use the coefficient of friction here. Okay, next we're going to find the acceleration of the system. So acceleration is just equal to net force divided by mass. And since they're both going to accelerate at the same time, they're going to accelerate together because they're attached together. So the masses add together. So this becomes F net divided by M1 plus M2. And that's equal to 4.6 newtons divided by 1.8 plus 3.8, which equals 0.823 meters per second squared. Okay, so the key idea is that the masses are accelerating together. They're attached together, so you add the masses together and make them equivalent to a single system moving together. Finally, we're going to find the tension in the cable. So just like we did with the pulley system problems from last time, we're going to isolate one of the masses. So isolate one mass and analyze it. In this case, we'll take a look at the 1.8 kilogram mass. It's probably easier since there's only two simple forces acting on it. So that's F net is equal to ma. So we make the equation for Newton's second law on that one mass. And we have F net is equal to Fg minus tension. So the sum of the forces. Two equations, and we're going to equate them together. So Fg minus T equals ma. And in this case, T, we isolate for T because that's what we're solving for. So it's equal to Fg minus ma. And then we can plug in our values. So we get 1.8 times 9.8 minus 1.8 times the acceleration that we calculated from the last step, 0.823, and that's equal to 16.2 newtons. Okay, so you're just simply setting up an equation for one of the masses and taking a look at the net force on that, which is equal to mass times acceleration, and then setting up a second equation for net force, which equals the sum of the forces, and then equating the two equations together and making a single equation. So that's the steps used to solve for the tension force. You can isolate the mass. You can isolate the 3.8 kilogram mass and try to solve for that as an extra, as a little bit of practice, and you should find that you get the same tension force. Okay, that concludes the presentation.